Good morning, guys. This is Mr. Evans here. Um, Today, we're going to talk about a continuation of the concept we did last week of lines, angles, and planes. And after that, we are going to go ahead and we are going to look at a little more with fractions and percents, converting fractions to percents, and back again. And also, we will start more work with adding, subtracting, and multiplying fractions if we have enough time today. Not sure just how far we're going to get. We will see. We're going to start off with a little bit of bell work. So if the lesson administrator will pause the video with this question that I write down. If you guys could please take 5 to 10 minutes to look at and answer this question, I will then give the solution and we will discuss it. Okay, your bell work for today is going to be hang on if I can get her to focus. So our bell work is going to be listing the factors of 51. Okay. This is your bell work, like I said. If you're one of the ones online, go ahead and pause it at this time and answer the question. If you are currently in class, if the person running the class could please pause the video, you guys go ahead and solve it, and then I will explain the answer to this question. Alright, so let's go ahead and talk about it. Looking at the factors of 51, okay, I have the first thing I can look at is see what is 51 divisible by. So if you'll remember from last class, 51, the sum of the digits of 51 add up to 6. Okay. 6 is divisible by 3. So remember, if the sum of the terms adds up to a number divisible by 3, we know the number can be divisible by 3. So what we're going to do is, let me get this lined up. Okay. 3 goes into 51 once. 2 goes into 21 7 times. Okay? So right away, we have 1 and 51 that are factors of 51, right? So 1 times 51. Then we also have 3 and 17. It's not an even number, so it can't be divided by 4 or 8 or 6. It doesn't end in 0 or 5, so it cannot be divisible by 5 or 10. Well, 10 can't divide into anything ending in 5, but you get what I'm saying. It doesn't end in 0, so it can't be divided by 10. It doesn't end in 0 or 5, so it can't be divided by 5. Let's see here. If you try dividing by 7, well, we know 7 times 7 is 49, and there's not 7 between 49 and 51. So 7 cannot fit in there either. And 7 is the only oddball that we would have to test for. And since we know the 7 doesn't work, our answer we're left with is 1, 3, 17, and 51. That is your bell work. The factors of 51 are 1, 3, 17, and 51. Okay, so now let's talk about what I want to discuss with you guys for today's assignment. So for today's assignment, we're going to talk about geometry definitions, which we briefly covered last week. Okay, the first definition that I'm going to give you is the definition of a line. Okay, the definition of a line is a set of continuous points that are connected. So continuous connected points. Okay, that stretch into infinity. In both directions. Okay. This line is a set of continuous connected points. Okay, hang on, let me let this to focus. Line is a set of continuous connected points that stretch into infinity in both directions. Okay, don't worry. If you give me just 1 second, I'll move the screen where you can pause the video and take notes on all of these, because I've got 3 more definitions I want to give you. Okay, a ray is a part of a line with one fixed endpoint stretching into infinity in one direction. Well, if I can get it to focus. Come on now. Stop. Well, eventually I'll get this camera to work. It's a new camera than the one I was using last year, so it's taking me a bit to get this figured out. Okay. So a ray is a part of a line with one fixed endpoint that stretches into infinity in one direction. A segment is a portion of a line with 2 fixed endpoints. Whoops. Help if I learned how to spell, right? Alright. Then a plane is a flat surface that extends without end in all directions and has 2 dimensions, length and width. Alright, and so I'm going to pull it back out here, or you can pause the video and go ahead and write this down, please. This is very important information. Okay, now that we got those written down, we got more definitions. Okay, if 2 lines cross, we say they intersect. Okay, and I'm going to give you some examples of intersecting lines here in just a second. If 2 lines never cross, we call them parallel lines. Okay. Perpendicular lines form a 90-degree angle on all corners whenever they cross. Alright. So these bottom 3 points right here, let's take a second to write these down. You can go ahead and pause the video and write that down. Alright, so now we're going to talk about some visual examples of all that stuff I just wrote for you on the other side, okay? This is what a visual example could be for a line, okay? If you see something looking like this on a graph, sometimes coming through 2 endpoints, or maybe even with a fancy letter, okay, is what we call a line. Array starts with one fixed endpoint and extends infinitely into one direction. Okay? A segment has a beginning and an end. Segment has a beginning and an end. A plane, okay, extends infinitely in all directions, has 2 dimensions, okay, your length, and then it also has width. Okay, it's usually designated with a small letter. Okay, that's what a plane looks like. 2 lines that cross, okay, so intersecting lines. Looks something similar to this. So this is line MN, this is line AB. They intersect at point, we'll just call that point J, right? Parallel lines are 2 lines that run side by side. Think about a set of train tracks. Okay, 2 parallel lines never cross. They run parallel or side by side to each other, never crossing, keeping the same distance apart. We call those parallel lines. Okay? So we'll pull all the way out on that, or you can go ahead and pause the video and make sure you got all that written down. For one last example, we have what they call oblique lines. Oblique lines, we didn't talk about this much. You don't hear this referred to often, but I feel it's worth a mention. It's 2 lines that are not parallel, so they intersect, but they're also not perpendicular. So they cross, but they don't cross at a 90-degree angle. Okay, we call those oblique lines. They cross at obscure angles. Okay, in this case, AB and CD are an oblique pair of lines. Okay, they don't intersect at a 90-degree angle, but at the same time, they're also not parallel. They intersect, but not at a special 90-degree angle. Okay. Speaking of angles, let's go over the specific definition of an angle. Okay. An angle is a construct formed whenever 2 rays share a common endpoint. Angle is a construct that's formed whenever 2 rays share a common endpoint. Okay? They could look something like this. Ray AB and ray AC create what we call angle BAC. The center point or vertex, which is the common end point, okay, the vertex or common end point always is the center of the three letters that you use whenever you're talking about the angle itself, okay? So that vertex always is in the middle. You start with one leg of the first ray, go to the vertex, and then come out the second ray. BAC, in this case. Sorry about that line in the video. That's the charger line for some reason. Deciding to be a pain in the neck. There we go. If I can get this thing to focus again because it's trying to lock itself. There we go. You can go ahead and write this down. Alright, so if by this point we have survived the first set of this lesson, so if we've talked about the geometric constructs and we still have enough time to proceed, I'm going to go ahead and discuss with you converting percents and fractions into each other, okay? So the first thing we will talk about is taking a fraction to a percent, okay? So say I have a fraction like 3/5, and I'm wanting to express it as a percent, right? I'm going to show you a quick and easy way to convert this to a percent. Percent simply means per 100, okay? So percent means per 100. So what a percent really is it's a fraction in disguise that has a denominator of 100. So what I can do is I can take the fraction in question. I'm going to set it equal to a fraction with a denominator of 100, or per 100. So we just need to find what the numerator is. Okay. So then, okay, cross multiply, because they are a ratio at this point. If this is set equal to this is a ratio, so I can cross multiply. 5 times x is equivalent to 3 times 100. Okay. Divide both sides by 5. X equals 5 goes into 30 6 times. 5 goes into 0 0 times. X equals 60. So it's 60 per 100, or just simply 60%. Okay. I'll let this sit right here. You can pause the video at this time if you need to copy it down, before I give you another example. So let's look at one that's a little different. Like, how about a little more complicated? So I have 13 over 100, or 13 over 20, and I'm wanting to turn it into a percent. So 13 over 100, I'm going to set this, I keep saying 13 over 100, 13 over 20, I'm going to set it equal to a fraction, here we go, over 100. For some reason my brain keeps wanting to say that. Okay, so then I'm going to cross multiply these. So I'm going to get 20x is equal to 13 times 100, which is this 1300. Okay, to find x, I'm going to divide both sides by 20. Okay, take a moment and try to calculate. Sorry, let me hold this still. This tablet is big and awkward. So 20 goes into 130 6 times. Okay. If we want to do the long division out on the side so you can follow it. 20 goes into 1300, like I said, 6 times. The remainder of 10. Bring down the 0. 20 goes into 100 5 times, with the remainder of 0. So, x ends up equaling 65 So the fraction is 65 over 100, or quite simply 65%. You can take a second and pause that screen if you need to. Write this down. Alright, at this point of the video, we are currently 21 minutes into the recording, which is likely going to be much longer for you at this point in the classroom. So I think at this point we will call it for the instructional portion, and I will cover more whenever I see you in class again. But what we're going to do now is I'm going to go ahead and give you a chance to work on your homework if you have time. Your homework that is going to be assigned on Google Classroom by the time that you're watching this video. If you do not have access to Google Classroom at the time in the classroom, what I'm going to do is I'm going to write out your homework on this paper so that you can see it and you can begin your work now. You can pause the screen, begin the work now, and then turn it into me on Google Classroom like we've been doing with all of our assignments at the end of the day. Alright, so here we are. Here's your homework for this week, the first half of this week. Go ahead and freeze the screen on this so that you can go ahead and take notes. Write this out on a piece of paper, and then whenever you get the first available opportunity, take a picture of your homework and upload it to the Google Classroom like we have been doing the last few weeks. Thank you very much, and have a fantastic day.